Yes. So, the year was 2010 something. And I had just been given the keys to my company's AWS account. It's more of a key card, but it actually looked like this. This is completely real. Management had spoken that we're moving to the public cloud. Think of all the savings. Think of capital expenditure to operational expenditure. This is like all the cloud things, you know, like economies of scale, elasticity, agility. Like we had the Kool-Aid had been drunk, and we were getting there. It was the future. It was very exciting. It was bold. And I was ready, because I knew so much. Or so I thought, because the fact was I was a junior. I had actually just graduated from college. It was my first real job, because apparently you can't count working 4 to 5 nights a week in World of Warcraft, raiding dungeons, I don't know. So the stage was set for greatness. The stage was set for degeneracy. So this is what happens when you open the AWS console back in the 2010 something. And this is where I was. I was there clicking with the mouse everywhere, like opening different things, you know, it was very exciting. I really liked what I was doing here. This is where you find your good toolbar up here as well for Bing and stuff like that. But most importantly, I was shipping compute now, so I had to go into the EC2 thing. And I went in there, and I was taking my time and figuring out how to do these things, and it's, of course, not the simplest thing in the world. But, you know, it was shiny, it was brand new, and I was going to figure it all out. So what I did, of course, is that I created a virtual private cloud, like my own VPC, as we call it, in AWS, because that's just what you do, right? Then I had my subnets all in order, because I totally knew what I was doing with that. That's something I had learned in school. Probably not, but maybe. We can pretend that I did. And then, like, with that, you also have to fix the security group, of course, you know? And then I, of course, opened all the ports that are relevant, you know, like port 22, port 80, and 443. Like, you know, the normal ports you open on a VPS. And then I found out that, of course, I need to open 8080 as well. That's where my application is running, right? Like, it's a Java application. Are you not running on 8080? Well, I was, so I did that, and I probably shouldn't have. But that's a different story, you know? So, like, when you don't really know what you're doing, it's just what happens. And then what kind of happened then was that I was approached by the rest of my team, and like, yeah, okay, so, like, very good. Now we got the staging environment up, and I'm like, yeah, you mean the environment, right? No, the staging environment. Now we're going to set up production. And I'm like, okay, but can we just use it for production? And they were like, no, I don't think we can do that. We need to have a staging and a production environment. And I'm like, well, yeah, I can do that. I can do that. I totally know what I did. I can reproduce that, right? Like, it's not a problem, because it's not like every click I had done was bespoke. It's not like it was like fatefully pressed that button. Maybe I did. That's what I say. It was like God was talking to me. He was like, click that button now. Click there. Click there. It was very exciting. But this was actually more like infrastructure as clicks. Some people call it ClickOps nowadays. I like infrastructure as clicks better, because it shortens to IaC. So that's quite nice. But so we had to have a meeting, because, like, obviously this was not working, you know? And they were like, but we need our infrastructure to be repeatable. We can't just, like, have somebody clicking an array in a console. That's crazy, you know? And then, like, a very smart guy in the meeting room, he was like, yeah, but, like, we can just use Confluence with screenshots, right? Yeah? No? But we could also use, like, JSON with CloudFormation. Like, we make a JSON file, we give it to CloudFormation. That's going to be great, right? And then a very smart guy was like, what about code? And no, that's crazy. You can't do that. You can't define infrastructure with code. That's completely out of the question. So, of course, we did Confluence. This is a picture of Confluence back in the 2010 something. So I managed to reproduce my steps, take a lot of screenshots, and put them in a Confluence page, and that's how we did infrastructure, right? Well, this was at least infrastructure as clicks. Then, if we had gone for the CloudFormation route, I would say that it's more like infrastructure as code. But what I want to talk about today is as actual code. Because what is the difference between making a huge JSON file or making some HCL files and stuff like that? Well, that is what we're going to get into today. So first of all, my name is Alexander Samsig. I work as a partner at Functive. That basically just means that I'm a bit too involved in everything, and mostly I'm a consultant. I'm also a part of the JavaBin, the Norwegian Java user group, where I am the chairman of the board, and I do events here in Trondheim. I'm also an organizer in BART.js, doing JavaScript meetups here in Trondheim, and I'm an organizer as well at TDC. So yeah, a bit of everything. I enjoy technology. I will leave it at that. So the agenda today, it's going to be quite a lot. I'm going to be speaking very fast, so I hope that you understand what I am saying. Luckily for you, I'm not speaking Danish. It's a favor to you that I'm doing, but I could do it if you wanted to. So the agenda, so what is infrastructure as code? We're just going to go through the basics of what is infrastructure as code, what defines it, what's the characteristics. Then we're going to talk about what I define as actual code. Then we have the provisioning engines, how it works under the hood. We're going to talk a bit about state, and we're going to talk about the infrastructure as code landscape, like what is actually out there, what solutions exist. We're going to talk about security, and we're going to talk about what makes Pulumi unique. And I'm going to show some short demos with Pulumi, how it actually works. And then we're going to wrap up, and I'm expecting all of you to applause in the end. I just make sure that we have a contract now. So what is infrastructure as code? Infrastructure as code means that you manage and provision your infrastructure using code instead of manual setup. So instead of clicking, as in my short story a little while ago, you are actually defining it through, for example, something like this. Usually it has been done with JSON, then we moved to YAML, and then people started inventing their own language to do this, because why the hell not, right? It's not like we have enough languages out there. We've got to make our own. But the benefits of defining it in code is that you get it to be repeatable, you can be consistent and always get the same thing, and you can version control it, and you can avoid and detect drift. So we'll get more into the specifics of what exactly drift is. But the moral of the story is that now we will actually be able to ship the same thing in different environments. So what is actual code? First of all, we have to describe a bit of the differences. So you can have something be declarative. This is usually what people will talk about when they're talking about SQL or HCL, like Terraform and stuff like that. And people will say that declarative is very important, you know? You can't have anything imperative. It has to be declarative. Basically, you're describing the end state, and some engine decides on how to actually reach the end goal of that description you've given it. It makes it very hard to express logic or expressions and abstractions, because the engine actually owns what it's going to do. So you if your language doesn't support it, it's very hard to make it do anything else. Imperative is where you reach the goal and step by step. You're making short commands saying do this, do that, do this, do that. It's a micromanager, basically. So you have full control over the execution flow, and it's easy to foot gun yourself, of course. Maybe you think that it's a smart idea to do something that it might not be. But Pulumi uses an actual real programming language. This is what they call an imperative host. We'll get into that a little bit more later. But it also has a declarative resource model. So that means that in Pulumi, you basically make a lot of resources. We'll have more code examples of that later. And those are interpreted declaratively. So that means you actually get to mix both the imperative and the declarative world and get the best of both worlds. So, a provisioning engine. The reason that I want to talk about provisioning engines is because I know a lot of people that use CloudFormation. They use Bicep and other proprietary solutions from the actual vendors. And the biggest fallback, or the biggest con of using those, is that you don't actually decide, you don't own what is deciding what to do, what decides what to do with the actual code. So you ship your code off somewhere and somebody else decides what the hell to do with it. And you have it's a complete black box, you have no insight into it. So you send the template to the cloud evaluates. Luckily, in this state, you don't manage the state. So when you use those, you don't have anything more to worry about than actually just shipping your instructions there. And all kinds of other niceties like drift detection is tied to the platform if it supports it. With the client side, like Terraform, OpenTofu, or Pulumi, you actually own the engine yourself, or the engine is open source, and you can run it on your own computer or your own CI or CD or whatever. The engine builds a dependency graph, and it plans a diff between the state that you have on your machine and what it thinks it should do to reach the new state. So here is a picture that's taken from Pulumi about how that works. So you have the language host and some kind of programming language that provisions resources, and the CLI or the engine reads from the last deployed state and figures out how to reach the new state, and it creates reads and updates against the providers that it's using. And with state specifically, location, locking, and secrets and stuff like that. So actually, we need to talk about state. Because as I said, state is not something you have in the server engines, you only have it on client ones. And that is because with state, since you are running the engine, you also have to keep track of the state that it needs to understand what to do. So the state is usually a large JSON file that holds all the values of your current resources and their values. It needs this state file to know how to mangle the state into something else. It exists basically just to do that and to plan the different operations as to do. An interesting question is, where can it live? Like most people nowadays, especially on the major providers like AWS, GCP, and Azure, you use a bucket or a storage account or whatever. No, it's not called storage, blob storage. And it handles, you can about handle it. Most of them have recipes that handle that for you. So basically, you're putting the file there, and you're using some locking mechanism to prevent concurrent access and stuff like that. But the big problem that you reach fairly quickly when you use something like Terraform is that you find out that this state is incredibly sensitive. Because when you're provisioning resources, like, say, a database, usually you have to give it a password somewhere, right? So that password will end up in the state file, and that state file is now in an S3 bucket, and if there's anything we know, is that S3 buckets, they fucking leak. You will leak, and you will leak so much data. Like, I don't think you can find anything that has had more issues than S3, and it's not S3 itself that has the issue, it's just that people, they mismanage it, they use it wrong, and they provision with the wrong, not credentials, but privileges. So all of a sudden, the bucket is public, and that is a recipe for disaster. So for compliance reasons, the state usually has to be encrypted at rest, which people then deem as good enough, and then we can debate if that is good enough. So the infrastructure as code landscape. So I have put up some logos of the things that are here as well. Of course, there exists other solutions as well, but these are the primary ones that I'm going to focus on today. So first off, we have CloudFormation and Bicep, as I talked about a little bit before. CloudFormation is AWS proprietary standard for infrastructure code, and Bicep is Microsoft's in Azure. They also have ARM, or the Azure Resource Manifests, or something. But Bicep is basically the new one, and will transpile down to ARM templates. So they are only for single cloud. You have managed state, which is an advantage. You have a server-side engine, which is an advantage or a disadvantage, depending on who you are. And you're using JSON, YAML, or Bicep. Bicep uses its own DSL called Bicep. Yeah, very interesting. And then we have Terraform and OpenTofu. I think we probably need to go into that a little bit now, and that is that Terraform and OpenTofu is pretty much the same. There was a huge debacle not that long ago, where Terraform, they changed the license on the Terraform core to be a business license instead, meaning that it's not truly open source anymore, which created a rift, and now there is a fork of Terraform that's called OpenTofu. So they are more or less the same. There is feature drift now. It has happened, and we'll get into a little bit about that later. But for all intents and purposes, they're about the same. They're about equal, and we'll get into the differences a bit later. They're multi-cloud. They're client-side. You have to manage the state, and it uses HCL, and HCL is HashiCorp configuration language. So it is not used by anybody but HashiCorp. Actually, GitHub Actions launched with HCL as the syntax to use to describe your GitHub Actions. And they quickly found out that, no way, we're not doing this. We're just going to use YAML instead. It's probably easier. Pulumi is also multi-cloud. It is also client-side engine. You have to manage the state, but you're not using some kind of configuration language or DSL directly. You're using a programming language with an SDK, which is kind of like a DSL, but it's inside your language, so you can use your language that you know and love. Then there's also the AWS CDK, the Azure CDK, which I've written in parentheses because it doesn't actually exist yet, but there is talks from David Fowler has talked about that he is experimenting with things, and it's not recent that he talked about it, but it could be possible. It maybe will manifest into something else in the end. There is also the CDK TF, which is for Terraform, so they call it a cloud development kit. It is basically like using a programming language to do your IaC. But in the case of exactly these, they all transpile down to the underlying format, so you don't really get to do any nifty tricks, which we will also get into a bit later. So security. As I mentioned, it is quite unlucky to have all your secrets and passwords and stuff like that in plain text in the state file. That is how it works nowadays in Terraform and OpenTofu. But they have recently launched a feature called ephemeral values, which I'm sure none of you have tried, because why would you? If you have, you can raise your hand if you have, but I really doubt anybody has. Oh, one. Was there one more here? No? No? Just one. So we'll get into more about what ephemeral values is in the next slide, I think it is. But then OpenTofu has actually, as I said, drifted a bit in features, and they now offer statewide encryption. So they have actually added features into the CLI directly, which make you able to completely encrypt the whole state. This makes it somewhat more secure, but you kind of have to remember that it does make more new difficulties, because encrypting the whole state is not necessarily what you want. But that's the thing about encryption at rest or encryption always. It's kind of like when it's in transit, yes, it will also be encrypted into the bucket and stuff like that, but it will also make it very hard for you to view it or parse it or do anything with it without actually having unencrypted it. So there is some small trade-offs. Pulumi does secrets encryption, or I could call it value encryption. Pulumi has the concept of a secret, which when you mark a value as a secret, it will now encrypt it into the state file. And it will no longer be allowed to be logged or used as an output value and stuff like that. The different encryptions you can use are a passphrase. It's the same for OpenTofu. So they have some kind of passphrase mechanism where you just give it like a password, and that encrypts it with that. You can also use KMS from the major providers for Pulumi, for the free major providers. For OpenTofu, they don't actually support Azure, not the last time I looked, which was on Friday evening. So I assume that is current. Then you can also use HashiCorp Vault or OpenBow, which again is also a fork of just HashiCorp's Vault, which was also a part of the Rift with the business license. Pulumi also has a managed service, which does the encryption when you use it, but then it also manages the state and stuff like that. Actually, it exists for Terraform as well, but I don't really know how you can mix it a bit with Pulumi, but I don't want to talk too much about the managed services because I'm primarily focused on the open source and free way to actually use these tools. So a small comparative table. We have the languages, HCL for Terraform and OpenTofu, and then the major runtimes for Pulumi. So you have Node.js, you have JVM, you have .NET, you have Go, Python, and YAML. And yes, I know that YAML is not a programming language, and yes, Pulumi knows that as well. It was very funny when they announced it, because they knew that, like, yeah, we've been talking about using real code or actual code, and now we're shipping YAML support, but it's more that as the end consumer of something, you can use YAML to actually provision your resources. So the idea is that you write the primary modules and everything else in a real programming language, maybe as the platform team, and then you give the product teams a way to provision resources with just a YAML file. That's the idea of it, at least. As I said, you have state, which is plain text in Terraform, which you can encrypt now in OpenTofu. And in Pulumi, I've written an asterisk because, as I said, you can use the value encryption or secrets encryption. Then when it comes to secrets, you have those ephemeral values. So ephemeral values, this is not a Terraform talk, so I don't want to go into too deep. But basically, you're telling Terraform that there's a hole in this value. I don't want you to ever record this value, which also means that the next time you're running a plan or an apply, it's not going to know what that value is. This also means that all the providers that you're using has to support ephemeral values, which makes it quite hard to adopt unless you're owning the providers you're using. And so more providers are shipping support for it, but it's quite early days still, so that's why I assume nobody is using it, because it is not something you can just go home and use now. Pulumi is encrypted, yeah, as I said. And when it comes to ecosystem, of course, Terraform is the de facto standard today. There's no way around that. If you can never go wrong picking Terraform, just like you never go wrong picking IBM. It's massive. And OpenTofu uses Terraform's ecosystem as well, and they also have their own registry in case that something should go wrong. And I don't think there's much drift in the provider space there. I would assume not. Pulumi also leverages Terraform's ecosystem, actually. So they have managed to create tools and infrastructure around basically auto-generating their own providers based on the Terraform providers. So that kind of means that a lot of the issues you might encounter using a provider in Pulumi might just be a direct Terraform provider issue. That means you are a bit more detached from the actual engine that's running it and what's going on. But I think it's a good cost benefit. So you get access to a huge library of providers, and they're also shipping their own native providers. For example, the Azure provider nowadays is they have a native provider and they have the Terraform bridge provider. But the native provider is completely generated through the Azure Open API spec that they have, that they offer, and it generates that nightly. So that means every night they regenerate the whole SDK and publish it. So that means that as soon as something is out in the API in Azure, you will be able to provision resources with that provider. The licenses are the business source license for Terraform core. They're using the business source license, which basically means that you can't use their Terraform core to do any thing you earn money from, basically. So that's where the big rift came, because other managed services that use Terraform and deploy stuff for you, they felt like they were not contributing, so they didn't want them to use that for free, and that's why that happened. Then OpenTofu has Mozilla public license, which has a weak copy left. So that means if you change any of the files that have the MPL license, you also have to provide it back there. But you are otherwise free to use it as you will. Apache uses, Pulumi uses an Apache 2.0 license, which is an open and free license, and you can do about whatever the hell you want with it. So what makes Pulumi unique? You can use actual code, as I've said, and you have the most popular runtimes. The reason that I listed runtimes before is because, of course, you can use both Kotlin, Scala, and Java on the JVM. You can probably use Groovy as well. I wouldn't recommend it, but sure. And you can use TypeScript or JavaScript. You can use Python. You can use C#, F#. Any F# people out here? No? No, I assume so. You have straightforward loops and functions and classes and abstractions. You can use your tooling you're used to. So like you have first-class IDE support because it is just your normal programming language. You open IntelliJ IDEA and you do whatever the hell you usually do, and that just works. There's no quirks. There's nothing wrong with it. It just works. You can debug in certain scenarios, and you can import resources with auto-generated declarations. So if you have a resource in the cloud, you can just give it the identifier and you can import it directly into your state via the CLI, and it will print out the actual definition that it has read from the cloud provider, and you can put that into your code and it will now be managed. You can also embed Pulumi via what they call the automation API. That is a way to use Pulumi as a full-blown SDK in your program. So that means that you can call the different CLI commands through a programmatic interface without having to resort to running CLI commands in your application. So let's get started with Pulumi. So this is my terminal, and these are the projects that I have created today. Let me just get my notes up for a second. Yes. So, first of all, I have cheated a bit. As you can see here, I have a file called env.rc. I don't know if any of you know what the dir-env is, but dir-env is a tool you can install into your shell and make it automatically propagate values based on an .env file. So I'm using that because to interact with Pulumi in the most efficient way without having to pull your hair out, when using a custom backend or using a passphrase, this makes it a lot easier. So we will jump straight into this one. So this is a Java application. Right now, we have not logged into Pulumi. So if we try and run Pulumi up is the same as Terraform apply. It will tell us we need to log in. That's, of course, a little bit annoying. To log in, you just type Pulumi login, and then you can use different ways to log in. You can use file, you can use S3, and all sorts of other things. Today, we are going to use file, but the thing is, you can also use local, but that local goes to your home directory. I don't really prefer that. I would rather have it directly in my file. So what I am going to do is I'm going to say log in, file, and just do it to the relative path. So now I'm logged in. Then we can try and run Pulumi up again. Then it tells me to create a stack. A stack is just an environment, so you can have different environments on your disk. We're just going to call it main. And then it's going to ask me to enter my passphrase, which is a little bit annoying, but I have to create it, so it's okay. So we create a passphrase. So now we're getting started. So this is like how you usually get started. You log into some kind of backend, state backend, and you define your secrets provider, and then you can run up. So the thing is, when we run Pulumi up again, it's going to ask for the passphrase because you need to pass the passphrase every time. But unless you want to like hard code the passphrase somewhere in your environment, you kind of have to change it all the time or something, and that is where dear end comes in. So I have prepared this from before, of course, so now I can run that. So if we can also just, we looked at it earlier, but now I have exported Pulumi backend URL and Pulumi config passphrase, so that means that every time I call Pulumi up, it is going to automatically propagate those into Pulumi. Right now, it's a bit upset with me, and I assume that is because a configuration thing is missing, and that is correct. So it's telling me that a required configuration variable is missing, and this is the Nginx version. So before we start looking at that, let's just look at the code. So this is a Java program. I know all of you are super amazed. You're like, wait, where's my class? Where's that public static void main? Like, what's going on? It says void main. How does this work? What have I done? This is Java 25, people. Java 25. I just had to like, yeah, put it out there, you know? It's not super useful, but it's cool. It's cool. You can just have a void main, and you're almost as good as every other language in the world. Then we have to run Pulumi run, and with that we get a context. And with a context, we can get access to different things, for example, the configuration. Also the stack name, and as I said, a stack is an environment. And we also can pick out things from the config. Then you have require, or you have get, and get will give you an optional because it's not sure, then you don't know for sure if the value is there. This is all pretty standard stuff. As you can see, I've chosen to import them with the full path. It doesn't look super pretty, but it is. I chose to do it for demo purposes, but also because Java has some fundamental issues with this kind of thing with provisioning infrastructure in this way. And that is that Java does not support aliasing imports. It just released with the module imports, so now you can actually define a module and import that. So I think that that could be very interesting to try out and see if you can fix some of the pains that this would otherwise give you. But the problem is that if I import namespace by itself, and I have used another provider that also uses namespace or deployment or something else very generic, I'm going to get conflicts in my imports all the time, and that's going to be incredibly painful. So for this demo, I've just chosen to do it like this, and I will admit that I do not think that Java is the best suited language to do these kind of things. But we will also talk more about that later when we look at some other languages. So we define namespace. I should probably say what this is. This is a Kubernetes manifest. So we're defining a Kubernetes manifest to deploy an Nginx server. So we have the Kubernetes namespace, and we have the deployment, and we have just created all the resources to do this. It's using the Java builder pattern, which is, again, one of the Java problems is that we do not have name parameters in Java, which means that to only supply some values into a constructor, you kind of have to get clever. And being clever means using the builder pattern, which I do not enjoy, but which is a necessity in Java when you do these kind of things. So that is why it says builder everywhere, and it says build everywhere, and it's a little bit annoying, but this is kind of like as good as it gets in Java at this point. It will probably never get better. I will admit that. It probably never will. But you can use Kotlin, you can use Scala, you can even use Java, TypeScript, or something else. So, but the advantage here is that with this, we can do some smart things. But first of all, we're going to fix the config issue, because we don't have that config right now. So we are going to use this suggestion that it gave us to set the value, and we're going to set it to 114.1 or something. It doesn't really matter if it exists. It doesn't really matter. And then we will run Pulumi up. We will open the project view. We will tell it that, yes, we want you to perform this update. We will open the output folder, because as you see here, it has now created a manifest. And this is because I have cheated a little bit. So Pulumi supports different things. So I'm not sure if you can see this. Is this too small? Is this better? Yeah. So I have configured the Kubernetes provider to use render to YAML directory and set it to output into value. This is, of course, for my demo that I thought this would be fun, but also because it's a real problem that I've seen, that teams that used to use things like customize and other things where you're stringly typing everything and just relying on strings magically being exploded or filled out and stuff like that, which is quite aggravating, especially as a developer who are used to using proper tools and code navigation. It is very infuriating to have those kind of things. So this is actually a manifest, and we have also set up this now with the version. So one of the things here is you can see that I've written Nginx how many times? This is say Nginx, maybe in quotes. So 5 times. That's a little bit annoying, right? So, but we're also using labels twice. So what we're going to do is we're going to take this. We're going to say, yeah, replace all occurrences. Yeah, just call it labels. And then of course, like it's a little bit willy-nilly on this. We're just going to call it bar. We don't care. So there we go. So now we're reusing the labels. Wow, this is actually quite nice, right? It's amazing. So what else we're going to do? We are actually, it would be quite nice if we didn't have to do a whole deployment every time. So what if we just take this whole thing, go down here, and we just click like this button. It's like, yeah, sure, like create deployment maybe. We'll call the method create deployment. Great, thank you. And it's like, oh, okay, it was a little bit stupid to have it in here. I'm just gonna remove this. Great. So it's a little bit stupid to have it in this file, you know. So we prefer to move it. So we're just gonna move it into deployments, and it's called a helper or something. Yeah, just create it if it doesn't exist. Yes, move static member. Great, great. Yeah, I'm gonna add it to Git. Yeah. So now we have extracted this into its own file where it can live and it can be happy. And we're like, oh wait, it says Nginx here. Why does it do that? Oh, that's so unfortunate. But we can just like select it and we can extract this parameter, extract all 3, and they just call it like app or something. Great, now we have extracted that, then we can jump right back to our old code and we can see here, oh, but we're using Nginx twice here. That's a little bit stupid as well. We can just like, oh, select that and we can extract. We just say app, whatever. Yeah, great. So like this is what I mean by being able to use your IDE, the tools you're used to, the things you actually know how to have a proper, effective workflow in. These are the kind of things that you get when you use a proper IDE with something you know, and not something like Terraform where you don't really know what you're doing and you're just using an HCL file and you're trying to define variables or locals that they call them, and it's just horrible and you're getting crazy. So then you do stuff like this. We're going to Pulumi up again, and there's nothing to do because it wasn't changed. We only changed the code, but it outputs exactly the same. Okay, so that was Java. Do we have any C# people here? Nice. So let's look at C#. I am not a C# developer. I won't say that. It's actually a very long time since I did C#. But today we are going to use another example here as well. Here we are using Docker. So like, of course, I don't think it's super fun to provision cloud resources because I don't want to show AWS and Azure and stuff like that. I would rather show that you can do all kinds of things. So here we are provisioning a Docker container using Postgres. So first we have a definition of a remote image, which means that it fetches the actual image from Docker Hub. So we're choosing to get Postgres latest. And then we are provisioning a container. And we are giving it the image from up here. And we're defining the ports, and we're defining the ends to like set the username, the password, and the name of the database. And in the end, we are returning a dictionary, which is what is going to be the output values of Pulumi. One fun thing to also note here is that this image ID is actually an output string, and that is because Pulumi has the concept of input and output is basically a monad. Okay, it's a container. It's because some of these values are not going to exist in the run like before at runtime, so you don't actually know what the value is. That means you have to interpret them in a certain way. This is a little bit of cognitive load using Pulumi, because you don't think about this when you use Terraform, because it's just implied that you don't know anything. You don't know what any of the values are. It's all resolved at runtime. But in Pulumi, some things can be known at build time, and some stuff will only be known at runtime. And that means you use something like output. An output is an eventual value, basically. And an input is a value that can take either a direct value or an output. So that is kind of like to bridge the gap about what would otherwise be painful. Okay. Okay, so we can run Docker PS. There is no Docker containers running. We're going to use Pulumi up. We're going to create a new stack. Just going to call main. We are going to create it. Great. So what I talked about earlier is that now we have the state in here, and we're gonna look for admin password. Wow, it's right there in plain text. That's not great. So what we're gonna have to do is we're gonna wanna do something about this admin password. So first of all, we can extract the substring, admin password. Then we could probably also say that maybe the admin password should not be hard-coded in the application. That's kind of silly. So we can say, actually, oh, we're gonna do like this instead. Config require secret admin password. Great, then we're gonna run Pulumi up, and we're just gonna say yes, we don't want it to ask us what to do. Then it's gonna say, oh, you can't do that because you have not defined the secret. You have to delete line 9. Line 9? Oh. I thought that was weird. I was very confused for a minute. Thank you. Yes, and then it's going to tell us that we need to define the value. So we're going to take that, and we're going to do like that, and we're just going to call it admin password, because we don't really care. Oh, I added a quote. Oh. There we go, pull me up. But now we have a new problem. Oh, calling toString on an output. And this is because this is an output value. That means you can't directly template it. This is quite unfortunate, and it makes it a little bit hard. But this is, as I said, some of the cognitive load that you get with Pulumi. But what you can do is you can use this helper method called output format, and then you can call it again. And we can also, just for fun, we can do like this. And we can say format is great. And then we do format, then format. Great, so we can output the password. But it doesn't output it because it's secret. So that is how it works with Pulumi, is that you can basically, when you require something as a secret here, it'll be interpreted as a secret. If we remove secret, it's not gonna be a secret. But also now we actually did a mistake, because when we made the configuration value, we didn't say it was a secret. And that means that in the state, or in the config, it's not gonna be encrypted at all. So what we can do instead is that we can say secret when we set it, run Pulumi up, and now it's encrypted in the configuration file. And I think it's going to be very upset because we didn't say secret. Actually, it did not care. It just assumed it was a secret, so that's fine. But now we also have the Docker container running. Docker PS, and Docker is running. Okay, that's C# for you, great. Okay, so I am not gonna have time to do everything today. So we are gonna do this quick one here now. So basically I have created a new TypeScript project, and I wanna show off Scaleway. So basically what we're gonna do is we're gonna call Pulumi import to import from our console. We have this, TDC. We're gonna call import. Oh, there is no stack. Okay, Pulumi up. We're just gonna call up. Choose stack main. There's nothing to do, so it's just gonna say, yeah, great, great. We're very happy with it. Oh, it's not the right ID. Okay. Did I not copy it? Jesus. And then it's imported into our state, and we get the code here, and you can paste it in. The reason it's protected is because it was not initially created by Pulumi, so it doesn't want to allow you to delete it. So now to delete the value, I would first have to run Pulumi up with protect on, and then I have to remove protect and say it's no longer a protected resource, and then you can run Pulumi up again and Pulumi down to remove it. Okay, I think that will be enough demo for today. So when you have to consider an IaC solution, I think you have to think about what is your actual problem you're trying to solve. What is your limitations? Like, are you using a single cloud, like only AWS, only Azure, or using multiple cloud? Are you hybrid, or are you on-prem as well? What kind of team do you have? Do you have developers on your team, and only developers? Then Pulumi might be a great solution. Do you have a lot of system operators or sysadmins and stuff like that? It might not be such a great solution, because if they don't know how to program, maybe they don't want to learn just to do IaC, because that would be a little bit weird. In a mixed DevOps team, maybe it would be worthwhile for some people to actually write the actual IaC, and for other people to just consume it through something like YAML with Pulumi. That might be a very nice way to do it. In that way, you would make abstractions on like the L2 or like the L3 level. But if you're strictly using L1 or L2, which means like very low level, so you're using every single resource that maps directly to a resource on AWS, then maybe Terraform is a better suited solution for you. But with Pulumi, it will be a lot easier to make abstractions and modules than it is with Terraform. The ecosystem and support we kind of talked about earlier. I think myself that Pulumi has more than healthy enough community, but of course you will have more community and more help and more people to find using Terraform. But it doesn't hurt to be a Terraform expert when you start with Pulumi either. So your decision guide, as I said, first party only. CloudFormation, Bicep, whatever else is first party. If you want multi-cloud and you don't mind the HCL, then Terraform and OpenTofu is probably great for your purposes. Do you want a developer experience that enables reuse and embedding infra into your apps? Then I would think about Pulumi. Why I like Pulumi, personally, is because it has a solid technical offering. It is developer-friendly and focused, and it doesn't get in my way when I want to do things. If I want to call some REST API to provision something, I can do that directly in my code. I don't need to find some hacky way to do it in Terraform using local provisioners or something like that. The cons are the paths are less traveled. Like there will not be as much help or documentation to find as with something like Terraform. And there is a higher learning curve and cognitive load in some cases, but I definitely think that it is something that most people will manage just fine. I can see that I am 1 minute over time, but I will take questions on the floor. Thank you.